This is a February, March 2023, variant 42 question, number 10. Part A. A student observed different stars from the Earth. Give two reasons why some stars appear brighter than others. In order to answer this question, which carries 2 marks, you need to understand that the factors affecting the brightness of a star. The answer given here is that number 1, the brightest star could be closer to Earth. Number 2, the brightest star could have produced a greater luminosity in the visible region so that the star can be more easily observed. Then part B, still as meant by a standard candle. A standard candle is an object with a known luminosity. Part C, the spectral line from the star within the galaxy is observed to have a wavelength of 660.9 nanometer. The same spectral line measured in the laboratory is observed to have a wavelength of 656.3 nanometer. In order to answer this question, you need to know that the wavelength for red light is 700 nanometer. The same spectral line on Earth is observed to have a value of 656.3 nanometer. And the value is increased, the wavelength is increased to 660.9 nanometer, as you can see from here. So the wavelength is now closer to 700 nanometer, the red light region of the electromagnetic wave. That means the wavelength is redshifted. Part 1. Show that the speed of the star relative to the Earth is 2.1 times 10⁶ meters per second. In order to answer this question, we must use this formula. This formula, delta lambda is a change in wavelength, which is 660 minus 656.3. And then your lambda here is the wavelength on Earth, which is 656.3 nanometer, equals to V. V is the velocity of the star or the galaxy, and C is the speed of electromagnetic wave, which is 3 times 10⁸ meters per second. So from here, we will get V equals to 2.1 times 10⁶ meters per second. Then for part 2, calculate the distance up to the star. The Hubble constant is given to you. Since the Hubble constant is given to you, we must use Hubble's law, which states that V equals to HOD. V is the velocity, which is calculated in part 1, 2.1 times 10⁶ meters per second. And D is the distance of the star from Earth. And HO is the Hubble constant. So your D equals to V over HO equals to 2.1 times 10⁶ divided by 2.3 times 10 minus 18. So this will give you 9.1 times 10⁻23 meters. Then part 3. State and explain what can be concluded about the universe based on this change in observed wavelength. You can see that the wavelength has increased from 656.3 to 660.9. The observed wavelength is redshifted. That's the first point. And then the second point is the stars are moving away from Earth. That's why it's redshifted. And then number 3 is the universe is expanding. And this is why we can come up with the Big Bang theory. This is a summary of the facts that you must know to solve this question. Number 1, you must understand the factors that determine the brightness of a star. The factors are how big it is, how hot it is, and how far away it is. Number 2, understand that the standard candle is an object with a known luminosity. Number 3, understand that the lines in the emission spectra from distant objects show an increase in wavelength from their known values. You must know what this means. Number 4, you must use this equation for the redshift of electromagnetic radiation to calculate the speed of a star relative to the Earth. Then number 5, use Hubble's law, which is V equals to HOD, to calculate the distance to a star. And finally, you must be able to explain how Hubble's law and redshift leads to an expanding universe and a Big Bang theory.